right, guys. If you can have worksheet number 2 out, we're going to do one problem from it, and then we'll move on to worksheet 3. Yesterday, during the review session at 4 o'clock, I went through the rest of worksheet 2. So if you want to see some of those problems worked out in detail, feel free to check out those the video I made yesterday. It's all going to be in the Help Sessions channel. And then today, in the Help Sessions, 4 o'clock, I'll do some additional of the worksheet 3 problems that if we don't get to them today in class. But worksheet 2, I want us to do a little bit more practice with sketching of curves, because you're going to see that on the quiz tomorrow. I want us to get more comfortable with it. And I also want to give some strategies as to how we can kind of break a problem into easier portions to handle. So on worksheet 2, if we can go to number 8, this is on the back, last problem. Okay, so let me, I want to talk about how I feel is the easiest way to kind of progress through this problem. So the first thing that I think is the easiest thing to do, let's go ahead and plot those points, right? Plotting the points, or just identifying some of the anchor points that the problem is providing for us. And then the second thing is we want to fill out our slope sine line, populate our slope sine line, or f prime sine line. Now, after we create our slope sine line, I think what's going to be the easiest way to go about doing this is we're going to sketch our first draft. And the first draft is just going to have your slope information. We're not going to worry about the curvature just yet. If you can have a first draft, then you can just kind of build off your first draft and just figure out the curvature based off the last statement. So after we sketch our first draft, then we can go and look at our second derivative sine line. And then from there, then we can do our final draft of graph. We can kind of fill in the details of the bare bone graph that we have in front of us. Okay. I think that's easier than trying to do, a graph with the curve, with the slope and the curve all at the same time. It feels like almost too much to do. So if we can have initial sketch and then build off that initial sketch, it's just kind of split up our process into easier parts. So first things first, let's go ahead and plot those points. All right, I have my plot. I have my points plotted. Now I'll turn my attention to my next statements. They're all involving f prime. So here's my f prime sine line. All right, based off of those statements, can you identify the critical points, the x values that we can place onto our sine line? Or what x values do they mention in those statements? 2 and 4, right? So we don't want to include 0, right? 0 is talking about slope. That's something else. But any time that we hear any mention of an x value, we're going to put that onto our sign line. Okay, let's go back to our first statement, our first f prime statement. F prime is less than 0 for x is less than 2 or x is greater than 4. What's another way of saying f prime is less than 0? Negative slope. Okay, where do we want negative slope?
Less than 2. Than 0.
Good, right. So if you can verbalize it into something that is visual, we can just transfer that onto our sign line, right? Negative slope to the left of 2 and to the right of 4. Okay, so now it's become more visual. We can translate this onto our graph later. Okay, f prime of 2 doesn't exist. Can you say this a different way?
F prime of 2 is undefined and vertical asymptote.
Okay, yeah, that's a possibility. What's another possibility? Another way of saying this? Yeah, so good. Slope doesn't exist. So slope doesn't exist. I'm going to think of it as a sharp turn. Now, if you want to make it a vertical asymptote, that works. I just find it a little bit easier just if you just do sharp turn, don't have to worry about a lot of other features about the graph, but it wouldn't be wrong if you did vertical asymptote. Okay. Well, actually, it does here. It says f2 equals 0, so the point exists, so that kind of forces our hand here. We have to make it a sharp turn, not a vertical asymptote. But if the order pair wasn't there, yeah, then we have some options to choose from. Okay, how about this next statement? F prime of 4 equals 0.
So it's 0 slope.
Okay, slope 0, good. Okay, next statement, f prime is greater than 0 between 2 and 4.
So positive slope.
Positive slope. All right. So this is what I want us to get to. If we can get from here to here, I think that's a good positive step. Any questions here? Does that make sense? Okay. Now we're going to translate this onto our graph. We don't know anything about curvature yet, but it's okay. I think having something on our graph is going to be helpful for our last step. Yes.
Can you go over how you got the negative, positive, negative?
Sure. Yeah. So it says f prime of x is less than 0.
Yeah.
So that's saying f prime is referring to slope. So slope less than 0 means negative slope. So we want negative slope when x is less than 2. So that's to the left of 2. And then x is greater than 4. That's going to be to the right of 4. Good. Yeah. Yeah. Any questions you guys have, please feel free to ask, because there's probably other students who are wondering the same thing and didn't want to speak up. So yeah, don't hesitate. Good. Okay. Any other questions? Okay, so from here, let's go ahead and sketch the graph. We don't know anything about curvature yet, but it's okay. I think if you do 2 sketches of your graph, as long as you make one more obvious than the other, then I know which one is your final graph. So I'm just going to you can use dotted line, or I'm going to use a pencil here. I want my graph to decrease to 2, relative minimum, increase to 4, and decrease after that. So it's not perfect, but at least I know the path of my graph. And then I'm going to update that later when I figure out how the graph curves. But at least I know the basic parts of my graph. I haven't included this yet, but eventually I do want a sharp turn at 2. And then eventually I do want a nice, smooth slope 0 at 4. Okay, all right, let's turn our attention to the last statement, which is talking about the second derivative. So let's create our second derivative sign line. All right, what's the critical point that they mention in this statement? Yeah, I know it says x doesn't equal to 2, but if they mention an x value, you're going to put it onto your sign line. Okay, it's going to be helpful. All right, f double prime is less than 0. How can we reword that?
Concave down.
Concave down. Okay, so where do we want concave down?
Everywhere but 2.
everywhere but 2. So to the left of 2, we want concave down. To the right of 2, we want concave down. So now we can update our draft of our graph and give it the full feature that So we want this basic path, right? We don't want any increase or we don't want any different slope except negative slope. So we need a negative slope all the way through, but we're going to give it a curvature. So let's make it this. Okay. It's not going to fully form in the parabola, right? It's just going to be a part of the parabola because the fact that it's decreasing, right? So I know you may feel like you want to finish this off a little bit, but it's going to have to maintain a negative slope all the way through. So the best we can do is just to give it that bit right there. Now, if it helps, we made that chart yesterday, right? So you know your chart has, it's either one of these 4 curves that you're creating, right? Imagine taking a circle and kind of breaking it into 4 parts. We want a negative slope with concave down, so negative slope, concave down. We just want that part to show up in our first portion. Sharp turn at 0, but then sharp turn at 2, but then after that we're going to go back to concave down. So the rest of the graph is going to have that concave down. It's going to be more full. It's going to be more of a parabola opening down. Slope 0, so be smooth at the top. So the initial draft kind of gave me a path to follow, and then the second draft, I'm just following along that path and just giving it a little bit more definition along the graph. Okay. So on the quiz tomorrow, you don't have to erase your first draft. You can just leave it like this. This will be sufficient. All right. Any questions? Okay. We'll do another one of these with Worksheet 3, but I want us to just have a couple of goes at these problems. Yeah.
How did you get concave down?
Okay, concave down. It's because of f double prime is less than 0. So if we have negative concavity, that's concave down.
For both?
For both, right? Because it says for x doesn't equal to 2. So what that means is, another way of saying that is everywhere except 2. So that means we have no concave up. There's no mention of concave up at all in our statements. So the most we can do is concave down on either side, and then neither at 2, but 2 separates our interval. And because of that sharp turn, that's where that break is occurring. It's neither concave up nor concave there.
Yeah. So if the sign would have been flipped, it would have been concave up.
That's right. It'll be concave up. It'll be difficult to sketch this graph with concave up in this format. So there's only certain scenarios that's going to work. Right. But I think that with Worksheet 3, we're going to see some more variety. So I think we're going to be able to get a little bit more variety with the second derivative that we'll explore. But for now, slightly easier problem, but still pretty involved. Any questions here? Good. Okay, so we'll build on this with Worksheet 3, but we're going to revisit the other topics first. All right, let's go to Worksheet 3. Number 1, find the critical points. If you don't have this sheet, I'm going to just highlight, make it easier to read here. Okay, so let's talk about number 1 here. Number 1 says, find the critical points. So can you guys highlight what steps you would take if you were just finding critical point?
Set
Set what equal to 0?
the equation.
Um,
Find for x. Set
so
equals 0.
yeah, the equal 0 is right, but what do we want to set equal to 0 though?
The x to the 8 plus x over the derivative.
The derivative. Okay, derivative. Yeah. So f prime. So you have the right idea. Just involve the f prime. So we're going to set f prime equal to 0. A couple of things I want to point out is when you find f prime here, it's not going to quite be ready yet. There's going to be some fractions that's out of place, so you're going to have to find a common denominator, clean that up, get it down to one fraction, because we need to look at the numerator and denominator as places where critical points can occur. So go ahead and try that. If you get stuck, it's okay, because I'm going to kind of follow up with each step along the way, but at least I want you to try it, because if you get stuck, it'll, your understanding will be a little stronger because you tried it. Okay, so let me show how our initial steps look. And you can tell me how you guys are coming along. So power rule, but my second fraction has a negative exponent. I'm bringing it down, and then I see clearly I have two fractions that's not quite ready to be pushed together until I can match with common denominator. Okay, any questions to this point? Okay, so next step, we need to find a common denominator, right? What's our common denominator?
5x
2/5, right? Good. So we know we want both of our denominators to be 5x to the 2/5. We can go ahead and try to balance those fractions out. So 5x to the 2/5. My second fraction is good to go, right? There's no changes, so my numerator is not going to change. But my first fraction, my denominator is not quite the same. The difference is I'm missing that x to the 2/5 with this first fraction, so I need to balance the top with x to the 2/5. So I need to multiply my numerator with x to the 2/5. If I multiply bases, I add exponents. If I add exponents, it's going to come out to be just 8x to the 5/5, which is 8x to the first power. Now we're ready. Now we have something clean. We can find critical points by setting the numerator equal to 0 and by setting the denominator equal to 0 separately. No need to check your intervals. You're just going to list out those critical points, and that's the end of the problem. Okay, any questions there? So what we achieved here is we found locations where a slope is 0 and also slope is undefined. But we want to include undefined slope as a critical point. So sharp turns are OK if we're looking for critical points. OK, good. Number 2 is extreme value theorem. Let's skip number 2 for now. If we have time, we'll come back to it, because I think we've done EVT pretty much every day, right? So we'll come back to EVT if we need to. Let's go to number 3, Rolle's theorem. Okay, Rolle's theorem, the purpose of Rolle's theorem is we want to find a location where there's a slope 0, where there's a slope. We don't care if it's a relative max, relative min. We just want to know, is there a slope 0 somewhere on our interval? But we have some conditions that we have to meet. We're not looking at a polynomial for number 3, so what stands out about this problem that you see?
has a vertical asymptote.
Vertical asymptote, okay. Just because we see vertical asymptote doesn't mean that our problem is not going to pass, right? We want to find the location of that asymptote. Where's the location of that asymptote? -2. Okay. Then we have to make a decision, right? Is that going to affect our interval? Or are we safe?
This one.
Okay. -2 is outside the interval. There's a break, but the break is outside the interval. Our interval is safe. Our conditions will pass. Okay. There's two conditions, right? It's continuity and differentiability. 95% of the time, if it passes the first condition, the second condition is also good to go. So on the quiz tomorrow, you don't have to worry about the second condition failing if the first one passes. There's only two conditions that you got to worry about later on. It's with odd roots or with absolute value functions. These are the only type that you're going to have continuity but no differentiability. But for us right now, if you can get that first condition to pass, the second condition will follow suit. Okay, so we know we have a smooth curve. Our intervals are good to go. But with Rolle's theorem, we want to guarantee a slope 0. So we have an additional condition that we have to meet. What is that condition?
Like an extrema? Like a
Okay. Something about the endpoints. What do we, if we want a slope 0, what do we need the endpoints to give us? Same y value. Okay. We need the two y values to be same, because if they're the same, we know that there's a horizontal line that we can be drawn, which can guarantee a slope 0 somewhere in between. So we need to confirm this, right? Rolle's theorem is very restrictive. We have to have a slope 0. So these endpoints have to be the same y value. So let's go ahead and find f of -1 and f of 3 and confirm if they're actually level with each other. If they're not level, then Rolle's theorem doesn't pass. Okay? So they have to be level with each other. They don't have to be zeros, but they just have to be the same y value. We need to guarantee that there is a slope of 0 between the endpoints. Okay, so that's what we're after. Okay, so find f of -1, find f of 3. But you're also going to take the time to write your conditions out. Continuous with brackets, differentiable with parentheses. Okay, the important thing is that these are the same what? Same values, right? Do they have to be zeros?
No.
No. So what if these are both 4s? Still 0, right? I'm still going to set f prime equal to 0. So I want to make sure that we don't think that because these numbers show up that we're putting a 0 here. It's because they're the same. Okay? If they're both 9s, you're still going to set f prime equal to 0. We're setting f prime equal to 0 not because of the location, but because of the slope. Okay? Because if these are both 5s, maybe the graph looks like this, there's still a slope of 0. We're setting f prime equal to 0 because there's a slope of 0 that sits between the endpoint. And that's what we're trying to guarantee. We're trying to guarantee a slope of 0. But it's only can be guaranteed if there's an actual horizontal line between, right? If we can't confirm a horizontal line between the endpoints, then our graph is not going to necessarily show a slope 0. We can't guarantee a slope 0. Right? Imagine if my endpoints is above each other. Right? Maybe the graph, maybe the graph just looks like this. Right? We can't guarantee a slope 0 if we can't, without looking at the graph, these endpoints have to be the same if we want to confirm a slope 0. Okay, so we know what we're targeting. We know we're going to find f prime. We know we're going to set equal to 0. So look at our function here. What's involved if we want to find the derivative? Quotient rule, right? Numerator and denominator. So let's go ahead and practice that. See if we can practice through quotient rule. Because that's going to be the slope formula that's going to help us find the location on the curve where there is a slope 0. So the derivative, careful with your steps. Distribute the negative through the parentheses. Now, with Rolle's theorem, when we set f prime equal to 0, we're only going to set the numerator equal to 0. But for number 1, we set the numerator and denominator equal to 0 when we're finding critical points. For number 2, EVT, we skipped number 2, but extreme value theorem is the same way, right? We find critical points from the numerator and denominator. But why in Rolle's theorem do we only look at the numerator of f prime and not the denominator?
As long as the numerator is 0, it doesn't matter what the denominator is, because it's going to be 0 still.
Okay, a little bit more. Why? So why not the denominator?
Because, like, let's say it's 0 over 1 or 0 over 100, so then it equals 0.
Okay, good. Yeah. So if we want a 0 value, it's just going to come from the numerator. Okay. Another reasoning is if you look in the denominator, then you're looking for places where slope is undefined, right? But that's not the purpose of our problem. Our purpose of our problem is slope 0. But yes, I think your reasoning of, if you're setting the right side as 0 over 1, if you cross multiply, the denominator is not going to be a factor. You're right, yeah. But with the extreme value theorem and the critical points, we did want sharp turns. But with Rolle's theorem, we only want slope 0. So the denominator is not going to make sense for our problem. So just the numerator. Now this was a little bit messier. We got to go through quadratic formula to solve for x. On the quiz tomorrow, I won't give you one. If I give you one, it'll be factorable. Okay. But what I want you to get out of this is the fact that you're going to get 2 solutions, but not every solution is going to necessarily be guaranteed to fall inside the interval, right? One is guaranteed, but if you have more than one, you got to double check, right? That second one may or may not fall inside the interval. So if we go through quadratic formula, we get 2 solutions. If you plug in the calculator, one value is safely between -1 and 3. The other y value is it's further left than -1, so it doesn't fall inside the interval. So there's only one c value. Yes.
This key is on the website, right?
Yes, it is. Yeah.
Okay.
Yeah. If you look at today's date, I have it as 2 separate documents, but there's a blank copy, and right next to it is the key. Okay, number 4, mean value theorem. Mean value theorem is similar to Rolle's theorem. We still need the continuity condition. We still need the differentiable condition. We're still going to plug in the endpoints into the function, but we don't need them to be the same. Okay? Because we don't need the slope to be 0. The slope can be 5, it could be 8, it could be any number. And then we're going to set f prime equal to that slope. So number 4, the nice thing about number 4 is it's a polynomial. So the first two conditions are going to pass without any issue. So we can move directly into beginning to work our theorem. So a lot of things going on here, but what should we do first? Find the y values, and then find the. Good. So I would encourage you to stay away from finding a derivative initially. Okay. Let's go ahead and get everything that we can from the endpoints, from the original function, from y value, slope. Let's get all that taken care of, and then we can turn around and find the derivative. If you find the derivative too soon, you may be tempted to try to plug in the endpoints into the derivative, and that's going to throw things off. So we're not going to plug anything into the derivative. So why? We're not going to do anything with the derivative to begin with. So let's let's just save it for when we are ready for it. So take your endpoints, plug into the function, get the y values, find the slope, and then find the derivative, and then set them equal to each other. Okay, so try that. Find your endpoints. Okay, you guys get a slope? You guys get 2? Good. So we have this side figured out, right? We know that this is going to be equal to 2. Now we can focus our attention on f prime. When we set f prime equal to 2, now we're going to figure out, okay, we know the slope to the endpoints is 2. Now f prime is going to tell us where else on the curve is there a steepness of 2. So find f prime, power rule. Set them equal to each other, and then solve for x. Now, if you get more than one solution, we gotta be careful, right? What x value is acceptable for?
The one in the interval.
Okay, what if it lands at the endpoint? Is that inside or outside the interval?
I think it's still outside.
It's still outside, yeah. So if it lands at the endpoint, it's not good enough. It's still outside. Good. So my derivative is just 3x squared minus 1. The slope target is 2. We set them equal to each other. There's actually 2 locations with the slope 2, but we only are going to keep what's in between because the -1 is close, but it's going to be slightly outside of our interval. We're not going to keep any endpoints, just what's in between. Okay, questions? Yeah.
Why do we set it equal to 2? I know it's a slope, but
Right. Why do we set it equal to 2?
just because it's a slope.
It's a slope, right? So this is what we have. Let's say the graph looked like this. Okay. Between -1 and 2, that's a slope of 2. So the purpose of mean value theorem is saying where else on this curve is there a slope of 2? So that's why we set f prime equal to 2, because f prime equal to 2 is going to help solve for x, and x is the location of that point.
Okay.
But with mean value theorem, with Rolle's theorem, we always set it equal to 0 because we have a slightly different agenda, right? We want to find a slope 0. So that's why we're setting f prime equal to 0.
Okay.
Good. Any other questions? Okay, let's come back to, let's go to the back page. 5 and 6. If we have time, we can go back to it, but I want us to now go back and practice the graphing problem again. So if we can go to the very last problem on Worksheet 3. Does anybody still need to copy this down? You guys good? So here is worksheet 3. So see if you guys can try the strategy that I just talked about with you guys. Multiple steps, right? Plot the point, create your slope sine line, sketch your first draft, then gather information about concavity, and then along the path of the graph, you can detail the curvature within each interval. Okay, so try that, and then I will follow up with the steps. Okay, what critical points do you guys put onto your slope sine line? Negative 1 and 2, okay. All right, first statement, what does that, the first f prime statement tell us?
The slope is negative.
Mm-hmm.
X is less than -1 and more than 2.
Good. The first and third region here, right? Good. All right, what does the next statement tell us?
Slope is 0.
Good.
Is equal to negative 1 and 2.
Smooth curve, right? Smooth curve, slope zeros. Okay, no sharp turns. Okay. Okay, next statement.
Slope is positive between negative 1 and 2.
All right, so we're going to take a pause and we're going to sketch the graph. Okay. It'll give us some visual idea and we can build off of that. So we want a relative min at -1, we want a relative max at 2, and we're going to go through all those points. Okay, I'm not worried about my curvature just yet, but I at least have some feel for how the graph is going to look, or where the graph is going to, how the graph is going to move. Okay, good so far? All right, let's move to f double prime. Let's see what information we can now gather that we can help give this a little bit more definition in terms of the curves. Okay, so based off the last two statements, what critical points do you guys see there?
-4 and 0.
Right. Anytime you see any mentions of x values, those will go onto your sign line. Okay. F double prime is less than 0.
Concave down.
Concave down. To the left of -4 and to the right of 0. F double prime is greater than 0.
Concave up.
Concave up. I want you guys to make some observations here. This is to the side. There's a change in sign, right? For second derivative. What do we call these? These are what?
Points of inflection.
Good. These are points of inflection. Okay. So these are the transition points, right? From one curvature to the next. I want to remind us again that there are 4 variations of curves. So I need to maintain a negative slope all the way through, but then along the way, there's going to be different curvatures, right? So all the way to -4, I want concave down. So I want negative slope and concave down, so I'm going to have this shape show up in that interval. Notice that I'm not going to quite finish my full concave, right? It's got to maintain negative slope, so it's not going to ever come, it's never going to have a positive slope feature to it. So yeah, so I know that sometimes students may want to continue, finish this process, but it's already negative slope, so we got to kind of follow that basic information that we've already built. But then there's a sudden change, right? What's going to happen after -4? Goes positive, so it's going to be different curvature, right? It's going to now resemble something that looks like this, concave up. But concave up is going to extend all the way to 0, so it looks like we're going to have that curvature all the way to 0. And then it switches again to concave down. So the rest of the way, we'll just make it more of a full concave down, right? It's going to have yeah, but just be careful with this, right? I think the tendency is we may sometimes want to continue making it, but it doesn't fit, right? It doesn't fit with what we've already established. We've already established negative slope, so we need to keep that property. Okay, no need to erase your draft. This is sufficient. Okay, we have some time, so why don't we do number 5 and 6 as well? So 5 is first derivative test. Find f prime, set f prime equal to 0. Create your sign line. Intervals of increase, decrease, relative max, relative min. So typically, I think students have an easier time with number 5 and 6. The issue with 5 and 6, though, students lose points because a lot of times they don't include because statements. So everything you write down, max, min, increase, decrease, you got to put a because statement after every one of them. Okay, so first derivative test for number 5. Okay, so let me show for 5, see how you guys did. And then for relative max, relative min, if you just give me the x value, that's good enough. But notice all these because statements, right? Got to include all of them. Okay, if you get done with 5, try number 6.
Mr. Yang,
Yes.
on the test, will we have to write on number 5 where it says relative max and it says -2, comma, and then you wrote in 20? Would we have to write that, or could we do x equals -2?
Yeah, you can leave those blank or just give me the x value. You don't have to give me the y value.
Okay.
Eventually, we will have to when we get to curve sketching rest of the unit, but I just want to keep reminding us, okay, how you would do it to find those y values back into the original function. But for tomorrow's quiz, if you just leave it blank or just give me the x value, that's good enough. Okay, no questions with 5. Try number 6. Number 6 is dealing with concavity, so we have to work our way down to the second derivative, right? Your process is going to feel like what you just did with number 5, but all the information that you're going to be gathering is from f double prime. Still a sign line, still critical points, but then they all mean something slightly different. Positive is no longer increase. Positive is now concave up. Negative is now concave down. And then your critical point is no longer potential max and mins. Now they're potential POIs. Same thing with 6. If you just give me the x value of the point of inflection, that's good enough. You don't have to give me the y value. But still, I want you to understand where that number is coming from if you were to find it. from the original function. Okay, any questions with 6? The only thing that is left off of this worksheet that I didn't, that's going to be on your quiz, is second derivative test. So that showed up on the second review worksheet. And remember, second derivative test is just you find f prime. So it feels like the first derivative test. You find f prime, you find the critical points from f prime, but rather than creating a sign line, you're going to dump those values into the second derivative function. And then you're going to look at the signs, right? Positive is going to be relative minimum because it's concave up. A resulting negative value from the second derivative is going to mean concave down, which means a relative max. And just being able to make those conclusions, okay, based off of using the second derivative test. Okay, any questions?
Mr. Yang,
Yes.
can you go back to number 6 on today's quiz review?
Yeah.
Thank you.
Does anybody else need to see number 6? Yeah, number 6?
Yeah.
Okay.
So why do we go to X double prime?
The reason why is because we're finding a different set of information. We want to find information about concavity. So that's curvature related. So curvature related is going to be from the second derivative. But if it's increase, decrease, slope related, then that's from that problem.
Okay.
All right, great. So study for your quiz. I'll have a help session this afternoon at 4, morning session at 7:15 tomorrow. Open notes, bring your calculator. Yeah, and then I sent out a reminder just within the last hour. If you're face-to-face, taking the quiz through Teams is not an option. Okay, so if you're not here, the test will not be released to you if you're face-to-face. And if you're not here, you'll just take it another day, either morning, afternoon, or lunch. Okay. All right, have a great day, guys.
Mr. Yang.
Yes.
So about the quiz tomorrow, or test, whatever it is. Quiz, yeah. So I'm gonna be on virtual for the next 2 weeks. I'm not 100% sure if, like, I talked to Mr. Spirito and he said I was like approved to go virtual for the next 2 weeks. So I'm not 100% sure if it shows you that I'm gonna be virtual, but I just wanted to let you know.
Yeah,
that
if you can send me a message, and if you can also, if it's not approved, if you can also just have your parents send me information, just so that just confirm that you are on track to be virtual, and then if that's the case, I will release the quiz to you online.
Okay.
Okay, thank you.
Thank you. Bye.
All right, have a great day, guys.